Okay, so I wanted to talk about this new ROS Tool capability because I think it's sort of it's useful to know about because it adds kind of a new way to communicate between robot cloud and web, specifically for ROS. So you'll find it on our capabilities page. And this diagram kind of says it all. It's it's really a React SDK to communicate with your ROS robots. So it allows you to subscribe to data, which you will, or subscribe to topics, which you will get, live and in real time on the web. The big difference with ROS-lib.js, if you know about that, or ROS Bridge, is that it goes through MQTT Sync, which is this protocol that we've developed in MQTT, which has a lot of the benefits over ROS Bridge. One of which is that all of the data is actually cached in the cloud, and I'm pretty adamant that that's the right way of building web front ends for robots, because with ROS Bridge, the setup is that you basically run a web server on the robot itself, and your web clients connect to your robots directly. And that's really cumbersome as your fleet scales for two reasons. Number one, your web clients need to be on the same VPN as the robot, which is almost never the case, right? Because you want to protect your robots, especially if you're running ROS, because ROS itself doesn't have any protection. So anybody who's on the network of the robot has full control over the robot, which you don't want. So you don't want every web user to share a network with your robots. Besides, if a web user wanted to use one robot versus another, they would literally have to switch VPNs, and of course that doesn't scale. So instead, we are routing everything through the cloud. The robot connects to the cloud in an inbound fashion and establishes the WebSocket connection. So you don't have to worry about any of that. You just have a web front end that allows you to communicate with your robot. You get the data, and if your robot is offline, you still have data. You just have the latest data because you're getting it from the cloud. So it's the normal back-end, front-end kind of setup, where, for a web page where you will always have a working web page. And then, of course, you can also publish, and you can make service calls. So that's sort of the diagram. And then I wanted to just show you a quick demo. I guess, yeah, let me show you the demo first. So the capability comes with I call it a playground. It's just a nice little UI. I'll make this a little bigger so it's easier to see. It's just a nice little UI where you can try it out. Again, it's supposed to be an SDK, so you usually use it in a programmatic fashion. But to try things out, it's nice to have a little bit of a UI. So the capability comes with this web UI that shows you, a subscription tab, a publication tab, and services tab. On the subscribe tab, you see all of the topics, both for ROS 1 and ROS 2, and you can subscribe to them. So, for instance, here I could subscribe to the turtle pose. I have a little turtle sim running here just for demonstration purposes, and this is live. So if I now use tailor up and control my robot, you can see these values are updating, right? And so this allows you to try out the subscription very easily. You can publish. So I could go in and select the twist messages type and publish that to the turtle1 command val, which, if you know turtle sim, is the topic on which you are sending basically motor commands to the turtle. And with that, I can draw some pretty circles here. I think I want smaller radius, right? So every time I'm clicking here, I'm sending a message, and then you can also use service calls. So for this one, the UI gets all of the existing services from the server and allows you to call them. And if there are parameters that you need to provide, then it actually fetches the schema from the robot live and provides you with a little template to fill in the values that you need, right? So for instance, here I could set the color of the pen to something like screen and maybe make it a little wider to make it obvious. And then as I start driving here, you see the color has changed. Yeah, there was a question, Javier.
Yes, right now you've set up a server in your or the MQTT communication in your terminal in your local computer, and you've put an address, and then the hosted web is connected to through that address.
Sorry, is
So
that a
connectivity.
question or?
Well, it's a question, yes.
Okay, so to get started, the easiest way is to use our hosted offering. So if you go to transitiverobotics.com, you can create an account. It's free, and then once you I can look at, once you do that, you can add a device. So on your robot, you would execute one of these two commands, depending on whether you want to run in a Docker container or directly on the host. And then once you do that, you see your device will pop up here in this list. And once it pops up here, you can click on it and you can see all of the capabilities that I installed. Initially, there will be none, but then you can click add capabilities and install the ROS tool. On this machine, which is my development machine in my garage, it's a little robot there. I have everything installed already, so nothing shows up under add capabilities. But once you did that, you would see the ROS tool here. You can click on it, and then you have this UI. And then you can go from there. You can self-host Transitive, and we have that in our documentation. If you go to documentation and under develop, you can read the introduction and then the setup. But that's a little bit more involved. I usually recommend that you first try it out on our hosted solution. Again, it's free, so with this capability, that you don't have to worry about anything like that. And once you have that working, you're happy. You can think about self-hosting.
Okay, thank you. And does this have any? I've seen that you put some commands to use it with Docker. Are there any security requirements, for instance, when using it with Kubernetes, that there are some ports that are not allowed or?
So when you run it in Docker, Kubernetes would be a cloud thing, right? So the Docker that we're talking about is on the robot itself. A lot of people nowadays run their software in Docker on the robot, and then they ship Docker images as a way of updating their software. So I'm not sure exactly what security concerns you're talking about there. Yeah, sorry. Maybe
Yeah, I mean, I refer, for instance, we in Asimovo, we are using Kubernetes for manage our cloud simulations. And for instance, for using ROS bridge, we need to open the specific port to be able to access, to connect a simulation in the cloud to our robot using ROS bridge or to my local computer. And we need to open the ports in ROS bridge. I don't know if it would be
no, you don't need to do anything like that.
Or...
No. You just when you look at the command here, this contains everything that you need, and so I've been building these types of things since about 2016, and I think I know what you're talking about. Some people build a setup, especially with ROS bridge, where you need to make inbound connections to the robot. That's garbage, right? You should never design your system like that. That's one of the issues that I was trying to describe with that architectural diagram before. Your robot is a robot. It needs to be a client, not a server, right? And
yes.
If you try to, that's what ROS bridge got wrong. In Transitive, this works differently. The robot makes a connection over SSL to the cloud. So it's just a normal outbound connection, which is why it always works unless you're behind some very restrictive firewall. So no, you don't need to. I don't think you need to open any ports.
Okay, thank you.
Yeah, so that's that's sort of the way to play with it. And then if you like it and you want to start developing with it, the actual code looks like something like this, right? I'm just going to walk you through it a little bit. This is clearly only for people who know React, but React is sort of de facto standard for web development these days. So it seemed reasonable to have first-class support for it. I guess quick question for people on this call: who here knows React and has programmed with it?
I'll put my hand up for that one.
Go around, Mike, John, and some hands exploded. I couldn't tell who that was. Okay, so maybe half of the people here who've used it. I mean, it's for those who haven't, it's a reactive web framework, so it allows you to, in some ways, it's like an MVC framework, if you know what that is, like a model view control framework, where you separate the display of the data from the model and controlling it. So very central to the idea of React is the state, which may change, and then rather than manually having to update your DOM as your state changes, React takes care of that. You just update the state, and then everything reactively re-renders therefore the name, right? So in this example here, we are creating a page called myPage. It's a component in React terms. It's a function that returns it returns HTML, but it's using that JSX syntax to create it. And the way that we've developed this SDK is as a context provider. So you give the context provider from our SDK a JWT, which provides authentication, but also specifies the capability that you want to use. And then within that context, you embed the actual component. In that component, you can then use that context. So this is how you basically get out from the context in which you're running the things that you want to use. So in this case, I'm getting out 3 functions: ready, subscribe, and device data. And then I'm waiting for the ready signal to come. And once we're ready, we are subscribing to a ROS1 topic called ACML post, which is, of course, the post that the ACML, the AMCL, the localization library, produces. And then I'm extracting from all of the device data just the AMCL post, and I'm storing it in a post variable. And then I'm just displaying it here, right? So post position X, post position Y. And so it's a very simple page that would just show the X and Y, very similar to what you saw on the playground. But I think it gives you an idea. And then apart from that, there are more functions that you can use. So there's the subscribe, which I just showed you. Unsubscribe, of course. There's the device data. We already saw that. That's the actual live data that you get from the robot. And then you can publish and make service calls just the same way. So personally, I think this is quite enabling. There's so many kind of web components that you need to interact. A lot of them are very custom to your robots or your specific application. And so in talking with our customers, this has been one of the most requested features overall. They didn't put it in those terms, but that's what they wanted to do, right? A lot of times people want to be able to, they often tell me, I just want to have a button that I can press and it makes a service call. Because then, that's kind of the connection, right? Like we understand how to implement service calls in ROS to do whatever it is, right? Like activate a motor, turn on the windshield wipers, whatever it is. But making that connection to the cloud, that's where there had been a little bit of a void. So that's the void that we were trying to fill. And because it's honestly not super sophisticated, we decided to make it free, so you can try it out, and it's sort of a way to educate people on the benefits of this approach. So please do try it out if you're interested, and let me know if you have any thoughts or feedback or questions. Yeah, Mike.
So something this makes me think of with the cache in the cloud is that you could use it for some kind of logging or ROSBag type functionality. Have you considered that? So
we do caching in the cloud in all of our capabilities, right? So what you are, the way that I would respond to that is yes, of course. However, that would probably be a separate capability. This one specifically is to connect it all the way to the front end and give a React SDK or API, whatever you want to call it, to communicate with the robot. For logging, that usually, the endpoint for that is usually in the cloud itself, right? And then in the cloud, you would typically do some sort of ingest. And then on the web, you would not want to show all of the data, right? Like loading an entire backfile into a web browser seems like a silly idea. But you might want to do something like selectively at specific timestamps or whatever, play back the data. So you would probably architect like a separate interaction between the cloud and the web front end there, which is why I think that would be a separate capability. But yes, at going down one level, so at the MQTT sync level, that makes perfect sense. And I've had some, discussions with one very large, like 10,000 robot kind of company about just that, and they ended up, they didn't go with Transitive in the end, but I managed to convince them that MQTT was the way to go. And I think that's a fine approach. MQTT sync honestly is a little better for that because it actually synchronizes data rather than just sending messages. But yeah, I think it's long story short, I think it's a good fit for logging.
Nice, thank you.
Christian, is there any more hands-on tutorial on the web?
Specifically for ROS Tool?
Yes.
No. I think, this page is really the entry point. There's a video that you can watch. What sort of, let me turn it into a question. What sort of tutorial would you like, or what would you like to see in a tutorial?
Okay. I mean, I would like to know, for instance, I know that I have to install the SDK. Imagine that instead of connecting a robot, just connecting my two laptops of mine and be able to visualize some simulated robot in another one.
Mm-hmm.
And I have a simulation where I have ROS Tool topics, and then I would have to start the SDK to send it over MQTT, and then in the other laptop, connect the Transitive UI to this robot.
No, you're overthinking this. We do what you're asking about is actually this tutorial. You don't once you understand how Transitive works, like just forget about installing anything. The only thing that you have to install is the agent on the robot, which is what the sorry, not that page. Which is what you see directly on this page. So once you created an account on transitive.com, transitiverobotics.com, you'll see a page like this. There won't be any robots. Then, but you will see these instructions. Then you typically, if you're just starting out and you just want to connect the two laptops, as you say, you would execute this curl command on the robot that pretends to be on the laptop that pretends to be the robot. So you're running like your simulation there or whatever. At that point, that robot, like after that script has run, will pop up here, and then you would open this page on the other laptop, right?
Okay.
And there you would then see this ROS tool, and from there you can use it. Does that make sense?
Yeah, and then every ROS Tool topic that I have put in because the ROS tool, I can select which topics I want. For instance, custom topics. I saw that you need to put that in the amend prefix path. Yes.
Yeah, you can do that. So we do support custom topics, and it's pretty straightforward. It's slightly different between ROS 1 and ROS 2, as is almost everything, as we know. But the change, the difference is very, very small, right? Like in one, it's the ROS package path, and the other one, it's the amend prefix path. And so then once that path is set correctly, and typically it already is, right? Especially if you have your custom messages just installed in opt, /opt/ROS/ your ROS release, whatever, humble /share. it will already be found because that's the default path. If you have it anywhere
Yeah.
else, you just set those path variables, and then when the ROS tool starts, it will automatically generate all of the message definitions from that.
Okay. Okay. Well, I see if I can try this week, and I'll let you know.
Yeah, sounds good. Yeah, let me know on email or Slack. We have a Slack link here at the bottom that you can use to reach me on chat. That's usually the fastest way if you need help.
Okay. Thank you.
There was a message on chat. Just FYI, we have ROS2 security enclaves to protect the endpoint that does not even authorize the participant to join ROS2. Okay, that's good, useful. No, ROSBridge doesn't do caching as far as I know. And how could it? Because it's a peer-to-peer connection, right? So there's no place for it to cache. On the robot, you're getting constantly the ROS topics, the ROS messages, so you're always live. And then on the web, you do use roslib.js, and so you could add some caching there if you wanted to, but that would be on you manually.
Christian, but the use case for the edge is like a connection is not stable. So I guess that if connection is gone temporarily, we are dropping messages, right?
That's right, which is why you should use ROSBridge.
Yeah, that's why I just care about like we are losing the data, and there should be some feature that caching a mechanism so that the chunk of data can be shooting after the cloud.
Look,
but I don't think so. I don't think
ROSBridge has been around for a while. It's a pretty old technology at this point. It's not supported anymore. I was on the Robot Web Tools working group with the Foxglove folks a year ago, and they were still supporting it somewhat, but they were so unsatisfied that they developed their own Foxglove WebSocket or Foxglove Bridge. Which was the right choice for them, also for performance reasons. It still follows the same architecture where it's a direct connection to the robot, and that's where I differ, right? Like I was the head of software at Savio. We had over 100 robots. That approach just doesn't scale. Like once you are getting into the dozens of robots and more, you absolutely want the cloud in the middle, and you want it to be sort of a star architecture where the robots talk to the cloud, the web talks to the cloud. And that's the middle point that provides stability, and that's where the cache belongs. So, rather than fixing ROSBridge, which I think is fundamentally flawed, I shouldn't say flawed. It solves a different problem, right? It's very useful when you're on the same local Wi-Fi network, and your connection is stable, and everybody is on the same local network. Then it's fine. You can run a web server on your robot if you want to. That's how we started at Savio. That's what they did before I joined. But you typically quickly outgrow that. So I recommend to people not even to go down that path to begin with.
And this same technology could be used to connect Foxglove, right?
To connect what?
With the Foxglove bridge with this.
So Foxglove Bridge is an alternative to MQTT Sync, really, because it provides a data transport between the robot and a web client, but it doesn't use a cloud in the middle, right? Now, if you want to use, we do have a capability that is Foxglove WebRTC, so maybe that's what you are thinking of, which is it's actually a fork of Foxglove because the normal Foxglove wasn't flexible enough, like in terms of extensions, to make it happen within that. So we forked that, and we added a new connection type to Foxglove, which is WebRTC. So that's it. But anyways, that's a little bit of a digression. But there are other problems with Foxglove WebSocket that may be a little too long to go into here. But if your connection is terrible, like Tomoya rightfully noted, then you don't want to use TCP, which is what WebSockets use. So Foxglove WebSocket is in some ways not the right approach. And you also want to do, video compression. So that's why we built that WebSocket as that WebRTC connector for Foxglove. This currently comes with the caveat that Foxglove is no longer open source, so this only works on the last open source version. But yeah, we have an alternative in the pipe that I can talk about in the future. I don't want to.
Yeah. Okay. Thank you. No, I mean, because we also have experienced some problems with the WebSocket connection and the ROS bridge and the Foxglove bridge. And in fact, I think we use Foxglove in Asimovo, but we don't use the Foxglove bridge because the ROS bridge works better for us in that sense.
And are you then on VPN, or how do you connect to your robots? Because your robot may not be where you are, right? They may be distributed.
Yeah, I mean, right now we are just talking about simulation and the web, a simulation in the server, and be able to see that simulation in Foxglove in the web solution.
Yeah. So Goran, yes, this is ideal for companies that are scaling their fleets. So like, most of our customers have like 5 to 30 robots right now. We're talking to some in like the 70 to 100 range. That's typically where you see those problems. That said, it's like what I'm trying to also point out is that companies that are much smaller, that have like 1 to 5 robots, where you typically do everything through SSH and manual, still benefit from this, because if you go down the ROS bridge path where you run a web server on your robot, you're digging your own hole, right? Like this will not scale, so you would then have to migrate a lot to the cloud. And the problem with that is that your architecture with the cloud is completely different, because the robot, like I said, will not be a server anymore; it will be a client. And so we did that at Savioke, right? And it was quite painful, and it took years to really complete it, where we could shut off the web server on the robot. So while it is not absolutely necessary for like less than 5 robots, because you can still do the peer-to-peer thing, I still recommend this approach, even when you're just starting out with your first MVP. I guess to understand better from you, perhaps, what's like, where do you work? How big is your fleet? What are your kind of constraints, Goran? You're on mute, so we can't hear you if you're speaking. Okay, cool. Yeah, so if a lot of students have come across ROS Bridge, because it's very useful to have a web UI for your robots, and a lot of people are learn about ROS Bridge. It's pretty prominently featured on the robot web tools. But like you realized from this discussion, it's a fairly old technology, and I think ROS Tool is really like the better architecture for that.
I have a question.
Mm-hmm.
What is the old technology? The way the ROS bridge is designed, or the WebSocket protocol?
My main issue with ROS Bridge is that it's unmaintained, right? So
yeah,
I'm airing a lot of criticism about the way that it is designed, and all of those you could overcome them, right? Like you could use ROS Bridge and go with more of an architecture like this one, even though that wasn't in the original intent of the authors. But they could do that. But the reason they are not doing it is because it's an abandoned child. It's just sitting there. There's like hardly any contributions being made to that. And things have changed too, right? Like when the robot web tools were originally created, that was still back at Willow Garage. That was at a time when there was barely any robotics companies operating in the world. The only robotics companies in the world were like the Kukas and Fanucs, were like the arms that don't use ROS. They are not even autonomous usually. So it was a very different time when that was created. And so the needs have evolved. So and the tools need to evolve with it. That's how I think about it. And I think Foxglove saw that. They saw different different reasons, like they had different constraints. They thought that peer-to-peer is fine, and for what they're wanting to do, that might be so. But if you're talking, especially, I guess the other thing that I'll point out is, this type of diagram, right? If you want to connect multiple robots, you really can't do peer-to-peer anymore, because you don't want to have one website establish 60 connections to 60 different robots on 60 different networks, right? You need some point of aggregation, and so that's where this architecture with a cloud in the middle seems like the right choice.
Okay, thank you.
Great. If there is nothing else, thanks for listening. If you have questions, you have my email, obviously, and you can try it out, or you can join our Slack and let me know what you think. I'd be particularly interested in hearing what people think about. I'd be particularly interested in hearing what people think this could be useful for. And if you do build something, please let me know. We can, write a blog post together on it and feature it on our new Cloud Robotics website or elsewhere. But yeah, would be really nice to collaborate.
And Ketan, I have one last question. Would this solution be helpful to watch the LiDAR or video, or that is too big, very big message for MQTT?
Yeah, video. I have a whole blog post on our website on it's called 5 ways to stream video from robots and why to use WebRTC. I recommend you take a look at that, because that's really the long form answer. I'll post it here. But really, no, you do not want to use TCP for video for several reasons, right? One, TCP will build up latency if packages get lost, because one of the features of TCP is that every packet will eventually arrive as long as it doesn't, expire for too long. So the idea is really to have to make sure that you get all of the frames, which is not what you want. If you have a little dip in network and you can't push everything through, you don't want to build up 30 seconds of latency, which is terrible, especially if you're teleoping a robot, right? So instead, you want to use UDP, where you can drop frames and always show the latest image, because that's what you care about. The other thing that you want to do is you want to do congestion control. So you want to reduce the image quality if the bandwidth dips, meaning like if your connection gets worse, you want to reduce image quality, not build up latency, right? So there's a lot of reasons why WebRTC was invented. We are talking over WebRTC here, right? Like Google Meet uses WebRTC. Almost all video conferencing uses that. It was designed for this purpose of live real-time streaming. So I strongly recommend that. If you just want to send image snapshots, some people want to see, like, show me the current picture, and then like not live, just in real time, but just one frame. And that's often useful for like teleassist or similar things. For that, you could use it. But I think that's the extent to which I would recommend it. Point clouds are in some sense even worse than video, because they compress very poorly. However, they are also like, there's no good video compression or like stream compression for point clouds that I'm aware of. So ROS Tool or something like that may be your best choice. But then I would recommend that you really compress it on the robot to just the essentials. If you're interested in point clouds, we can chat offline, because we're working on another capability specifically addressing that problem. But yeah, that would be a separate discussion.
Okay. Yeah, I think that it might be interesting to have another conversation this week or next week.
Okay, sounds good. I'll can you shoot me an email about that?
An address, you mean?
Can you? Yeah, I'll send you my address in chat.
Okay.